So now let's do a basic static friction example for an inclined plane, and I would know this before taking the FE exam. So we're told here we have a box shown below that has a mass of 50 kilograms. This box has a mass of 50 kilograms. The coefficient of static friction, so this is friction, between the box and the inclined plane is 0.25. So this box and the inclined plane, this is the inclined plane, this is the box, they come in contact, right? So there's going to be some friction developed, and we're given that coefficient of friction. So this is actually what variable? It's always denoted by mu. And we're looking mu static. So we're looking at static friction, and it's 0.25. Static meaning nothing's moving. Everything's at rest, right? If we're moving, we will have kinetic friction. But here we're focused on static friction. So this is the coefficient of 0.25. We're asked that the minimum horizontal force F in newtons required to hold the box from sliding down is most nearly what? So what's happening here is we want to inhibit the motion downwards. So we do not want the box to slide down this way. So we want to find the force that will inhibit that motion downward, right? What is that force required to hold the box from going down, sliding down the incline? So this is what we will find. This. Let me highlight that. So it's going to be this. So that's what we want to find, and we're given that the mass, let's just write that here, is 50 kilograms, right? So I'll write that as a given. Those are the only two variables we're actually given, and what we want to find is that force F. Force F to keep it from sliding down. So the scenario is important when you're doing these, right? Sometimes they will ask, what's the force F to push the box up? So that makes a different case. Here we want the force F to keep this from sliding down. So we're gonna say F in Newton to keep box from sliding down the incline. I'll just say down. Okay, so we have that, and we're given the angle here, the inclined plane angle. So we want to pick the answer for F. So what do we do? The first thing is obviously to do the free body diagram, right? So for our solution, let's write the first step. Step 1 is draw free body diagram, FBD, and we're gonna say we're gonna do this above. See above. So I want to do it on the actual figure instead of to save time. So let's just use the actual figure, draw the free body diagram. So the body we're looking at is the box, right? So we want to free that body from its surroundings and just isolate the box and draw all of the forces, in the interacting forces on the box. And one thing I want to stress here for an inclined plane, make sure you reorient the axis. It makes the work a lot easier, and that's actually what I'm gonna do first, is denote our new x prime and y prime axis to make our work easier. So usually we're used to the axis is being this, right? This is x, this is y, and what we'll do is reorient it to have the x-axis as an x prime axis along the parallel of the plane, and we will have a y prime axis normal to the plane. So normal, and normal meaning perpendicular and parallel. So this is going to be my x prime, and I'll denote this. Again, it's going to be normal to the plane as y prime. So this is the new axis we're going to look at, right? We're going to use. So we have that, and now let's draw the free body diagram. We know this box has a mass, therefore it has what? It will have a weight. So let's just denote that first. And the weight acts at the centroid. We're going to call this W of the box. And we know what's the equation for weight. Weight equals mass times gravity, right? mg. Weight equals, in this case, what's the mass? It's 50 kilograms. So I'll just write that as 50 kilograms, and gravity for we're looking in SI units, it's always 9.81, right? 9.81 meter per second squared. Okay, we have that. Let's just solve for this. So if you do 50 times 9.81, you should get 490. So 490.5 newtons. So I just solved that real quick, but we know that's acting vertical, right? We said our new orientation, we're taking everything with respect to the y prime and x prime. So we need to break this weight that's vertical into a respective component along the y prime and along the x prime. So the component along the y prime will be, I'll call it W. So the weight Wy prime, and the component along the x prime is going to be this, right? So we should be good with these from statics. This is Wx prime. So I'm just denoting the respective components for the W, for the weight. So we have the weight. What else do we have acting on the box? Something called the normal force, right? This box is sitting on a plane. It hits the plane, and we know for every action there's an equal and opposite reaction. So the reaction is the normal force here. It's going to go up, and it's always perpendicular, right? It's perpendicular to the box in this case. So this is the correct orientation, so it's acting strictly along the y prime. So we have that. Then we have which force? We have something called the frictional force. But the tricky thing here, is it going to go up? So is it going to go up this way or down? The way you arrive at the direction is by looking at the question. We want to find the minimum horizontal force required to hold the box from sliding down. So the box is trying to slide down, right? So that means the frictional force always resists the direction of motion. Since the box is trying to slide down, the frictional force is going to be going up, right? So this is our frictional force. And we know the frictional force, we know the force of friction is always denoted by this equation, mu times n. Mu times n, which is the coefficient of static friction times the normal force. So that is always true, and that has been proven in experiment. So it's always mu times n for the frictional force. So I'll just write that here, mu times n. So we have the frictional force, and the last thing, I want to break up the components for this force, because this is horizontal, right? And we said the new orientation is this. So we want to have an x prime component and a y prime component. So let's denote this F. So the first one I'll call the Fx prime, and we will have one that goes along the y prime axis. This is Fy prime. And one thing here is this 30 degree, wouldn't you say it's the same as this angle, right? So this 30 degree is the same as this. So that's the same angle. And one last angle, which is somewhat tricky, is going to be, where is the 30 degrees here? Is it this or this angle? In order to break up the components, we're gonna need this angle. So is it here or here? Where would we put the 30 degrees? It would be here. So it would be there. And to quickly prove that, let's quickly say that we have our normal orientation. So this is the y-axis, this is the x-axis. So this is vertical axis, horizontal axis, and we know gravity is always going down, right? The weight is always acting toward the center of the earth. So this is the axis that we always start with. But we know here we reoriented the plane 30 degrees counterclockwise. So we're going to have a new axis, and this is the x prime axis, right? So we know that we rotated the inclined plane, how much? 30 degrees. 30 degrees. And this is the new x prime axis. So we started from this x-axis, we went to x prime, right? What we do to x prime, the y-axis also changes. It changes to what? Y prime. It changes to y prime. So it has to do something like that. So this is going to be our y prime axis. Y prime. So this rotated by 30 degrees for the incline counterclockwise. So it will do the same with respect to the y axis. So this is 30 degrees. And we know that's 30 degrees. This has to be 30 degrees, right? This has to be 30 degrees. Meaning that's actually 30 degrees. It's actually this. What we have here in this case is actually what we have, right? If you actually look at it closely, think of the weight as going down here in the center, right? That's the weight. So that's 30 degrees, that's 30, and that's just one way to prove it. So we have all of that, and I believe we have all of what we need to begin analyzing this thing using statics. So with statics, we know we simply apply force equilibrium, right? So let's say apply force equilibrium. And we know we're doing it along what axis, what orientation is going to be the x prime, y prime, right? So the first one I want to do is going to be the sum of the forces along the y prime, right? Because that usually helps us determine the normal force, but in this case it's not actually useful, but let's just stick with that. We'll do the sum of the forces along the y prime first. So sum of the forces along the y prime axis, we know it must equal to 0 because we're looking at statics, right? So now let's extract all of the forces along the y prime. The first one I see is this Fy prime. So let's go down and write that. So we have Fy prime. And that's going to be going this way, so it's negative, right? And one thing I didn't denote is this way is going to be positive along the y. So if it goes this way, it's going to be negative. So this is negative. Negative Fy prime. So we have that. Then what do we have? Let's see. We have the Wy prime. It goes down, right? So it's going to go into the inclined plane. So it's going to be negative, right? So it's minus Wy prime. Then what else do we have? We have the normal force. It goes up. So it's positive. So plus n. And I think that's it. So all of this equals to 0. So now let's break these down further. You could have done that in the first step, but I'm just trying to denote everything here. So Fy prime is going to be what? It's going to be the force. Is it sine or cosine? It's going to be sine of 30. So Fy prime is going to be the magnitude force F sine of 30. So to break this down, we're going to do negative F. So keep that negative. Sine of 30 degrees. Then we do minus, we're looking at Wy prime, so it's going to be this component. Is it going to be cosine or sine? So it's touching the angle of 30, right? Anytime it's touching, it's cosine. Just remember that. That's one way to memorize it. Or think of trig, but I won't go into that real quick for the sake of time, but this is going to be cosine. Since it's touching, it's always cosine. So it's going to be W, it's the weight, the magnitude, cosine of 30 degrees, and we do plus n equals to 0. So we have that, and I think let's plug in what we know. So we do not know this. This is actually what we want to find. And we do not know this as well, but we have the weight, right? The weight is going to be 490.5. So I'll break this down further. Negative 490.5 newtons cosine of 30 degrees plus n equals to 0. And one last step I want to do is solve for this in terms of move the whole value of, basically move this to the right side, and you'll see why we do that to solve a system of equation at the end. So what I'm going to do is take this value and move it to the right side. Take this and move it here. So if you do the math for this value, we get about 424 0.79 newtons, and I'll just leave everything on the left, so it's going to be this plus n, and then we leave this, right, minus F sine of 30 degrees. So we're going to say this is equation 1 for force equilibrium along the y prime. I'll call it equation 1. And we'll use this and combine equations at the end. But now we did along the y prime. Let's do the exact same thing, but now along the x prime, right? This direction, parallel to the plane. So now we do sum of the forces along the x prime equals to 0. And we're going to say that going this way, everything that goes in that direction is positive. So now let's extract the values. So the first one I see is this, fx prime, right? So it's going to be that. So I'll just write that just like what we did for the other one. So fx prime, and it's positive because it goes in that direction. Then what we have is negative wx prime. So negative wx prime. What else do we have? We have this force of friction, right? So we have the force of friction, and it's positive, right? Plus the force of friction. And all of this should equal to 0. So let's break this down further. This fx prime, is it going to be cosine or sine? It's going to be cosine, right? It's touching the 30 degrees. So it's going to be the force, this force magnitude cosine of 30 degrees. To break this down, right? So it's going to be the force cosine of 30 degrees. Then we do minus the wx prime is going to be this one. So it's going to be negative, right? We said that. And it's going to be sine, right? It's not touching the 30 degrees. So it's going to be sine of 30 degrees. So it's going to be the weight, the magnitude sine of 30 degrees. And we do plus the frictional force we said is what? Is always mu times n, right? So we're going to say that equals to mu times n. I'll just say mu is this. It's for static. And n is going to be this, right? The blue. The normal force. And all of this should equal to 0. So now let's just plug in the weight real quick. So rewrite in this. It's going to be f cosine of 30 degrees minus, what's the weight? The weight is going to be 490.5 newtons sine of 30 degrees, and we do plus, and that is going to be for static, right? So it's 0.25. That's given. We said that at the beginning, times the normal force, and all of this equals to 0. So now let's do the same thing we did here. Let's move the value we can actually calculate to the right side and get something similar to equation 1 we have above. So I'm going to take this value, move it to the right side, so I'll just rewrite this. It's going to be f cosine of 30 degrees, and we have plus, so let me keep the same. It's going to be plus 0.25 n, and this equals to, the weight is going to be on the right side, so it's going to be 245.25 newtons. So it's going to be this value, right? And moving it to the right side, it becomes positive. So we have that. Now we're going to say this is going to be equation 2. Okay, so now you have two equations, right? One equation, two equations, and how many unknowns? Two unknowns, right? The two unknowns are the force and the normal force. The force that we need to find and the normal force, normal force. So two equations, two unknowns. We can actually use substitution, the elimination method, or even the calculator. So real quick, I'm just going to use the calculator. So now if we use the calculator, this is the TI-36X Pro, which is allowed on the FE, and I believe you can do it with other calculators as well. What we will do is use the system solve function. You just do second system solve, and it's a 2x2, and then let me actually clear all of this and make sure we're in degree, right? So you do second system solve, enter, So it's gonna be the 1x, so it says 1x, and the 1, in this case, the x is actually gonna be the f value. So let me denote these. This is gonna be the x value, this is the y value, this is the x value, this is the y value that we want to solve. So those are the unknowns. So it's going to be 1x, but we know it's going to be negative, for that x is negative sine 30. So we do negative sine 30 for that. Actually, you have to, I put a minus sign, so you have to do negative sine 30 for that. So it's negative 1/2, because sine 30 is 1/2, so it's negative 1/2. So that's there. Then we do plus n, so plus y, so plus, so there's just a 1 right in front of the y. That's fine, but on the right side here we have 424.79. 424.79. Okay, so that's equation 1. We do the same thing for equation 2. So for this, it's positive f, which is the x value, cosine of 30. So you do just cosine of 30. Then you do plus 0.25. So the plus is fine. And this is 0.25 times y, which is the n value, the normal force, equals to 245, which is this value, 0.25. Okay, so we have everything. You just click solve. And we get the x value to be 140. Again, what's the x value? It's the force, right? And we also get the y value, which is the normal force, to be 494 or 495. But we're mostly wanting the x value, right? That's what we want to find, the force. So it's going to be around 140. The force equals to 140 newtons. So this is actually the answer. And again, this was the x value on the calculator when you use the system solve function. So that's going to be 140. And again, this is the force to keep the box from sliding down. Sliding down. That's the force we need. So now for you, so obviously this took too long, but for you, can you find the minimum horizontal force, F, required to push the crate or the box up the plane? So in this case, you want to find the force that pushes this thing, the box, up the plane. So that means the motion of this box is going up, right? The only thing that changes is the frictional force is going to be acting this way, right? Because it resists motion. The box is trying to go up. The frictional force will go down, and all you do is apply the same steps. You just change this and solve for that force. So let me know what you get in the comments below, and I think that's it for this. Thank you.